Hello, this is Jeremiah Robinson, and this is my extra credit video for P.1 through P.3. And starting off with real numbers, there are four categories here. A being for natural numbers, which are just normal counting numbers, whole numbers. B is for integers, which are positive and negative whole numbers. C for rational numbers, which are radicals, that repeating numbers, and D is for irrational numbers, which are non-repeating, non-terminating kinds of decimal numbers or radicals. So starting off here for A, the number would be 4. Then next in the category, it would be -75 and 4, because the other numbers wouldn't count. For the next one, it'd be -4.63, and root, and also it would be point 7575. And then for the final one, it would be the 2.3030030003 dot dot dot, which is ellipsis. And the root 10. Okay, just root 10 here. And that would be that. Now, we are going to do a problem from P.2, 32A. And for this problem, it is a simplify the expression where we have negative z to the third, or cubed, times 3z to the fourth. And now to work out this problem, you're going to want to get the z's together, and since it's a multiplication problem, you're going to add the exponents, because you add exponents on multiplication. So basically we can really split the problem into 3 times negative z times negative z cubed times z to the fourth, like this, in which case we would get 3 times negative z to the seventh, and that would be our answer. Our next P.2 exercise is another simplifying, and here we have 4y times to the negative 2 times 8y to the fourth. And now what we're going to do is we're going to take the y to the negative 2 power, and we're going to put it underneath the 4. So we're going to have 4y squared normal. This is going to be times 8y to the fourth, and we can just go ahead and put that over 1 to keep the problem on track. And now we're going to have 32y to the fourth over y squared. But since we have the same variable with our exponents, we can subtract the exponents, starting with the numerator over the denominator, and we will have a total answer of 32y squared. Now for this next problem, we're going to have a minus a to the negative cube over b to the negative cube times a over b cubed. Now this problem's going to really take some steps, so follow along. Since we have a negative cube, we will of course flip each, and since it's on both the numerator and denominator, we can just write the problem upside down from here. So b cubed over a cubed times, and since the exponent is outside of the parentheses, it applies to everything inside the parentheses, so it will be a cubed over b cubed. Now, as you can see, now we can subtract, and 3 minus 3 of course is 0, so basically what we end up with is b over a times b a over b, which honestly, and that's all to both to the 0 power 0 0 0, and anything to the 0 power is going to equal 1, and we could just cancel that out and have just 1. And there's your problem. Okay, so here's our last problem, and it is a p dot 3, and what we're doing here is essentially we're multiplying two polynomials. So we have 4x to the 4th plus x cubed minus 6x squared plus 9, and then that we're multiplying it by x squared plus 2x plus 3. And now what we're going to want to do is we're going to want to FOIL, but instead of foiling like normal, we're going to have more to do because we have more terms, so follow along. We're going to first multiply the 4x to the 4th times x squared, so there's 4x to the 6th. Now we're going to multiply 4x to the 4th times 2x, which is going to be plus 8x to the 5th. And finally, we're going to multiply the 4x to the 4th times 3, and we're going to have plus 12x to the 4th. Now, keep following along. We're going to have our x cubed times the x squared, which is of course just going to equal x to the 5th, because remember, the reason why all of these are this way is because exponents, when you're multiplying them, you add them together. So moving along, we're going to have x cubed times 2x, and that's going to equal 2x to the 4th. And finally, we're going to have 3x cubed by multiplying x cubed times the positive 3. Now, we're going to have more terms here, so follow. And remember, we're at the negative 6x squared, so make sure to keep track of your signs. So we're going to have minus 6x to the 4th now, because we multiplied the negative 6x squared to the x squared. And then minus 12x to the 3rd, and then we're going to have minus 18x squared. And now we've hit the end of the stretch here of the foiling, so let's just go ahead and finish. We're going to have 9x squared with 18x, and finally 27, because remember, we're going to multiply the 9 into each term on the other polynomial. And now You might think we're done, but we're not, because we have to go back and make sure that everything is put into the simplest form. So here we go. 4x to the 6, because that's going to just stay because it's got no other terms. But we're going to take all the other terms that have other like terms and add or subtract them. So like 8x to the 5th and x to the 5th is going to be 9x to the 5th, 12x to the 4th. Actually, let me just box that real quick. Here we go. Add back our plus sign here. Keep things together. But 12x to the 4th and 2x to the 4th are going to end up being 14x to the 4th. And our to the thirds. Oh, wait, we can't forget 6x to the 4th. See that? You have to keep track of those kind of stuff because it will happen. So here we have 20x to the 4th, because of course 12x plus 2x is 14, and 6x plus is 20x to the 4th. Now we have our 3x minus 12x, 3x to the third minus 12x to the third, or 12x cubed. And so we're going to have minus 9x cubed right there. And then negative 18x squared plus 9x squared, of course, is going to end up equaling negative 9x squared. And then we have plus 18x. And of course, that's just because that would be the only one here with an x value left. Just the one x value. And plus 27. And here is our finished product of an answer. Remembering that we keep these terms together, and I'm just going to go ahead and do funky shapes for the other terms to keep them together here. And squiggle, 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 squiggle. And yes, there we go. That is that problem, and the end of the first video.